Alright, in our previous video, we looked at these calculations and we found our marginal cost, marginal revenue, and marginal profit at 50 items. So, our marginal cost was 6,200. Now, the total profit function at 50. All right, let's write down the total profit function again. All right, let's start from the cost. Total cost function 62 x squared plus 27 500. 62 x squared plus 27 500. So Cx was 62x squared plus 27 500. Then we had Rx. What was Rx again? I remember it started with some type of x cubed thing, but let's look back at it. The revenue from selling x item, x cubed minus 12x squared plus 40x. So this was minus 12x squared plus 40x. Was there a plus 10 there? I think there was a plus 10. Plus 10. And then our profit, total profit, was x cubed minus 74x squared. So our profit, x, was x cubed minus, what was it again? X cubed minus 74x squared. So it's minus 74x squared. Then what came after that? Plus 40x. So there was a plus 40x here. And there's something else there. What was it? Minus 274.90. Minus 274.90. Alright, good. Now, Cx at 50. Or C prime at 50. Our marginal cost at 50 was 6,200. Alright, so C prime 50 was $6,200. Alright, you know it's dollars. I don't want to crowd the board with too much writing. In fact, let's do this in another color. 6,200 for marginal cost. R prime 50 was what? The marginal revenue at 50 was 6,340. So it was 6,340. 6,340. And then P prime of x was 140. So we got that when we use the derivative of the function. Now remember, the marginal cost is the cost of the next item. The marginal cost at 50. Now, what would be the cost of the 51st item? Let's look at something before. Let's look at a few notes before. Here, see the marginal cost using derivative is approximately the cost of the next item minus the cost of the present item. x plus 1 would be the next one in line. X would be the one now. The marginal revenue using derivative is approximately, not exactly the same, but approximately the same as the revenue of the next item minus the item now. And the marginal profit would be approximately the profit of the next item minus the profit of the item now. Let's use that method and see if it would really work out for us. Now, here, what would be the cost of 50 items and then the cost of 51 items, and subtract them? So C50 minus, or C51 I should have, C51 minus C50 would be what? The C51st item would be 62 by 51 squared plus 27,500 minus the cost of 50th item would be 62 by 50 squared plus 27,500. So let's work this out and see if we get something close to 6,200. 62 times 51 squared plus 27,500 equals, we have 188,762. 188,762 minus, all right, 62 times 50 squared plus 27,500 equals 182,500. 182,500. Suppose we subtract those numbers now. Let's see what we would get. We have 188,762 minus 182,500 equals 6262. Quite close. This would be 6262. Very, very close. Right? Now, let's see what happens with revenue. The revenue at 51 minus the revenue at 50 would be equal to, revenue at 51 would be 51 cubed minus 12 by 51 squared plus 40 by 51 plus 10 minus, to go into minus now, it would be 50 cubed minus 12 by 50 squared plus 40 by 50 plus 10. So let's work it out. We have 51 cubed, 51 by 51 by 51 is what we have. That's 51 cubed minus 12 by 51 squared. Give us that, all right. Plus 40 by 51 equal, plus 10 equal 103,489. So we have 103,489 minus, and then we work it out again using 50. So we have 50 cubed, which is 50 by 50 by 50 equal, all right, minus 12 by 50 squared, that's what it gives us, plus 40 by 50. Okay. Plus 10. And we have 970, 10. So 970, 10. When we subtract these, what do we get? We have 103, 489 minus 970, 10 gives us 6479. 6479. All right. Close enough. All right. So we had 6340. Now we have 6479. Close enough. And then here we want to find out the profit as well. Profit at 51 and the profit at 50, and subtract them. So here, profit at 51 minus profit at 50 equals profit at 51. That's 51 cubed minus 74 by 50 by 51 squared plus 40 by 51 minus 27 490 minus, I have to go in the next line. This one is extra long, we're running out of space, so that's minus 50 cube minus 74 by 50 squared plus 40 by 50 minus 27 490. All right, what would that be? So let's do the calculation. For 51 items, we have 51 cube, which is 51 by 51 by 51 equals that, minus 74 by 51 squared, you get that, plus 40 by 51, all right, minus 27490 equals, we have negative 85273, negative 85273 minus, and then this one now, I'm going to do the calculation again, but this time for 50. We have 50 by 50. Let's do that again. 50 by 50 by 50 equals, all right, minus 74 by 50 squared equal, all right, plus 40 by 50 equals, okay, minus 27 490 equal negative 85490. Now this would amount to the same thing as negative 85273 plus 85490. What do we get now? Let's see. This is negative 85273 plus 85490 equals, this is 217. This is a bit far. Let's recheck it, make sure everything is all right. X cube, that's 50 cube minus 74, 51 cube minus 74 by 51 squared plus 40 by 51 minus 27490. All right, that's the profit. And then we redo this. 50 cubed minus 74 by 50 squared plus 40 by 50 minus 27,490. Let's redo the calculation with the 51 again. 51 by 51 by 51 equals, all right, minus 74 by 51 squared equal, okay, plus 40 by 51 equals minus 27,490. 27,490 equals, we have negative 85,273, all right, and the one with the 50 was negative 85,490. So what we had again was negative 85,273 plus 85,490. 85,490 equal, all right, let's accept it. 217. So in this case, this one is not as near as the previous ones, but what we have here are values that are close to when you differentiate it. When you use the derivative to find the marginal values, that's the accurate value. When you calculate for this item, then the next item and subtract them, that's approximate. It's not as accurate. The derivative gives you the accurate value. Now, let's look at, for example, the cost function. 62x squared plus 27,500. Right? Let's look at using our graph to do it. Let's use our graphing calculator to do it. Taking quite a while to load. All right. So we're going to plot the function for the cost. All right. The cost function here, 62x squared plus 27,500. So what we have, 62x to the power of 2. That's 62x. All right, to the power of 2 minus, what was it again? Oh, plus 27,500 plus, these are some very large numbers, plus 27,500. All right, what we're going to have to do is zoom out of the graph quite a bit to see that graph. We have to keep zooming out and out because they are really very big numbers, right? We are in the hundreds, we are in the thousands now. Right, we soon reach the 10,000s. Okay. I want to zoom out enough to see that graph and the values. I'm still not seeing the values here. Let's try again. 62x squared plus 27,500. 62 x. That's 62x. If we square the x, to get my batteries up and running again. Alright, let's square the x to the power of 2. Alright, we still have to zoom out quite a bit. Alright, still not seeing those values. I'm still not seeing the graph. Right, the 62x squared. Those values will be too large for us to accurately see exactly what's going on in the graph. It would be too steep. But the general shape of the graph would be this. When you look at the graph generally, it would look like a quadratic function, right? Now, if you had used, for example, 6x squared plus 27, right? If it was smaller numbers, 6x to the power of 2, right? It would be looking more like that, plus 27. I would have to redo the scale. I'm seeing both graphs here. The steeper one would be the 62x squared, alright? Steeper one would be the 62x squared plus something or another. But anyway, the general idea here is that it would look something like this. Now, at 50, let's say this is 50. When you draw a line, the tangent line to that graph, so this is our tangent line, alright, and 50 is here. You're finding an accurate value. If 51 was here now, the line between that, it would be a chord between 51 and 50, and it would be a little bit off. Alright, so in this case, the gradient of the line, the gradient of the chord would be a bit different from the gradient of the tangent, right? As you can see, the gradient of the chord, which is approximate, right? This was the grade. Oh, yeah, this was the gradient of the chord. This one was the gradient of the chord, a little higher than the gradient of the tangent, right? So, looking back at it, the gradient of the chord, when you draw through both points, would be a little higher than the gradient of the tangent. So that's why you had different values. And when you subtracted, when you found the cost at 51 and the cost at 50 and subtracted them, you got a value that was a little higher than the value when you use differentiation and found the derivative at 50. But the derivative at 50 is the accurate value. The derivative, finding both values and subtracting them give an an approximate value, but certainly not very accurate. Alright, so that will be it for now. I'll see you in the next video.